Hi everyone, this is Mr. Hall, and this is a really quick video about fuel cells. This kind of follows on the heels of the last video done on chemical cells. This is a little bit different, and it's specifically focused on hydrogen fuel. So the objectives of today's video are threefold. Firstly, is to state the balanced symbol equation for a hydrogen fuel cell. It's pretty straightforward. Secondly, is to state the half equations in a hydrogen fuel cell. I'll probably talk quite a lot about this one in particular because I want to communicate exactly what's going on in terms of the movement of electrons in those half equations, because if you understand that, then you really understand how fuel cells work, basically. And then finally, I'll very quickly go through the pros and cons of a fuel cell, basically evaluating them. So why are we learning about fuel cells? The thing to think about is just where we're at with regards to fuel. At the moment, our economy is very much still driven by using fossil fuels like crude oil, etc. And at the moment, we're running out. Now, the graph here is basically showing peak oil production when it's projected to be. And basically, if we haven't reached peak oil production already, then we're probably going to reach it very soon. And what peak oil production basically means is the point at which a particular nation or the Earth in general is at its maximum sort of production of million barrels of oil per year production-wise. And this graph here, which you can find online, basically states that in certain parts of the world, we've either reached peak oil production capacity or it's coming up very soon. And once you reach peak oil, basically it's downhill from there. So each year, because you have less and less oil, you produce less barrels from the stores that you have. Okay, so this is obviously very troubling. We're running out of oil and we need to find other fuels in order to kind of fill in the gap which is left by this dwindling reserve of fuel that we have. So what we have is a problem where we need to find a fuel, ideally one that doesn't pollute and can fill that gap. And hydrogen is such a fuel. It's quite exciting. It's relatively new fuel, and it works on redox chemistry. Now, in a hydrogen fuel cell, hydrogen reacts with oxygen to produce water, which can be shown by this equation here. Pretty straightforward from the way it looks. However, the chemistry in terms of the redox is a bit complex. I mean, it's basically combustion. That's basically what you're doing. But the chemistry involved from a redox perspective is difficult. Okay, so I looked online, and if you look online, there's loads of like GIFs, animation, videos which show you how this particular cell works, but it doesn't really show you the kind of detail that is required to understand, particularly from the AQA GCSE spec, what it knows like, you know, it's quite prosaic, but it is what you need to know. Now, this diagram looks like a bit of a mess. I'm not like a wonder artist at this kind of thing, but I think it shows you the bare essential of what you need to know. The key thing is you've got this kind of central area. This is the electrolyte here, so I'll just label it electrolyte. All right. And on either side of it, these are the electrodes. Okay, so here's one electrode, and here's the other electrode over here. Okay, and you've got these two sort of containers side by side. On the right-hand side here, this is where oxygen will flow in before doing what it needs to do, and I'll talk more about that in a second. And then this is the electrolyte where fluid can go across, particularly this OH minus ion, which I'll be talking about quite a lot. And then here, this is where hydrogen comes in, and this is where hydrogen and oxygen combine to form water, and then this is where the water departs. The yellow circles represent the electrons which flow around this whole thing, and then here I've got a bulb just to kind of signify the fact that this is like a working circuit. Okay, so that's the electrochemical cell. That is the fuel cell, basically. Let's talk about the right-hand side first of all. Okay, so we're going to talk about oxygen and what happens there. Okay, so when oxygen first comes in, it's over here. And when oxygen first comes, now I've got water here in the middle in the electrolyte, and I'll explain why in a minute, because the electrolyte basically is a dilute solution where there is water inside it. Now your oxygen is pumped into the fuel cell, and it will go across the electrolyte, or the electrode rather, and it will go straight to the electrolyte like so. Now, once it's in the electrolyte, it will dissolve in. And when it dissolves in, it will react with the water there in order to produce hydroxide ions. Okay, so if this is my oxygen, it will basically separate up, and then the hydrogens will move across like so. And it will create 4 lots of OH minus ions. Okay, so the half equation that happens at the electrode of oxygen that is shown at the bottom. You got your oxygen, it reacts with the 2 molecules of water that we had before, and then it creates 4 lots of these hydroxide ions at OH minus. Now, as it does that, it needs to have an extra electron in order to form the OH minus ions, okay? So these electrons that are coming over here in this kind of mixed circuit will come here in order to help form that bond, all right, like so. So one goes there, one goes there, one is going to go over here, and one is going to go over there. Now you could go into massive detail about like electron counting, working out why that extra electron's needed. And if you count the electrons in the oxygen molecule and you count the electrons in water, you'll find that in order to make 4 lots of OH minus, you'll be 1 electron short for each of them. And that's where the extra electrons on the right hand side here come into play in order to make that possible. Okay, so that's your first step. That's on the electrode on the right. So you've got 4 lots of OH minus. Now I've sort of positioned it here, and you'll notice I've drawn 2 electrons on the outside. Now that kind of makes sense. They're basically the lone pairs. If I'm just to draw what it looks like over here, here's oxygen and here's hydrogen, and they share a shell like so. If I was to draw just the full thing, and I've got dot cross here, cross, 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 and cross. These 2 electrons are these 2 here. Okay, so I've just kind of redrawn them rather, and it's important for you to understand that they're there for the next step. Okay, so carrying on. So we've got hydrogen. Now hydrogen is pumped in on the other side of the cell, and it flows in like so, and it can also sort of migrate across into the electrolyte. Now what happens here is that the hydrogens basically split up to form hydrogen ions, and then they will react with the hydroxide ions that have come across in order to form 4 molecules of water. Now, when it does that, think very carefully about the number of electrons that you've got. Now, remember, hydrogen had a lone pair there. Now, when you start, water had a lone pair there. When you start off with hydrogen, hydrogen is very simple. It's just this with 2 electrons like so. In order to form 2 lots of H+, it has to get rid of both of those electrons. So what you've got is H+ here, H+ here, but then these 2 electrons need somewhere to go. They're picked up by the electrode and sent to go round the circuit. So effectively, those 2 electrons that it's lost, these 2, is this electron and this electron. Okay, and they go around the circuit and they'll light the bulb up, and then they're used again in order to break down more O2 to form hydroxide ions. Okay, and the 2 electrons, the lone pair here on the OH ion, are used to form that new covalent bond with the other hydrogen to form water. Okay, so you've got those 4. Once you've formed those 4 waters can now flow away and exit like so. Okay, now if you think about it, that is a half equation because you've got 2 lots of hydrogen which have broken down and they've joined the OH minus ions to form 4 lots of water, and they've got rid of 4 electrons in the process. That half equation is shown here. Okay, so you've got 2 lots of hydrogen plus 4 lots of OH minus to make the water, plus the 4 electrons. That's the electrons that you've lost over here in order to make the whole thing work. Okay, so we've got 2 different half equations. So that's basically how it works. Now, if you look at the half equations, you've got 2 of them happening in this cell. Okay, you've got one on the left and one on the right. Lots of this stuff can cancel. All right, so if you have them side by side, you can see first off that the electrons on the left and right can cancel. You can see that the OH minuses can cancel as well. Now, in terms of the water, those 2 on the bottom one can cancel. I can't cancel all 4 of these. I can only cancel 2 of them. So instead of getting rid of all of them, I have to redraw it as 2 lots of H2O. Now, what I showed here a little bit too early was the overall equation for this reaction. 2 lots of H2O I'm left with, which is here. 1 lot of oxygen I'm left with, which is here. And the 2 lots of water, which I was left over after cancelling on left and right, is here. So that's the overall equation for this particular electrochemical cell. 2 lots of hydrogen plus 1 lot of oxygen makes water. It's effectively the combustion of hydrogen. Now, this cell is very exciting. There's lots of pros associated with it. In terms of the pros of them, you don't need to electrically charge it. As long as you've got hydrogen and oxygen, get them reacting and they'll create electricity for itself, which is quite exciting. Also, no pollutants. All you create is water, which is great. In addition, you can use it for a range of sizes for different uses, for lots of different devices. So there's lots of pros associated with hydrogen fuel. However, there are some cons. One of the cons is that it's very flammable, okay? So hydrogen is very explosive, very low flash point. So if you were to have like a hydrogen fuel cell on your car, you're basically like a driving bomb, okay? As long as you crash or something happens, you're not going to last very long. So it's very, very difficult to store, which I'll come to in a minute. Also, hydrogen produced for this cell is often done by non-renewable resources. Now, one of the common ways in which you produce hydrogen is basically by using fossil fuels. Now, that's not a sustainable way of doing it. And that's one of the problems with hydrogen cells at the moment. And then the final issue is it's difficult to store. Now, if you go back to the earlier thing which I was talking about, which is having hydrogen fuel cells in cars, very flammable, very dangerous, it's very difficult to store as well because you need like high pressure. It's tough, okay? So it's not an easy thing to carry around and it's not very practical to use in comparison to petrol, which you can put it in a car, and whilst petrol's flammable, it's no way near as flammable as hydrogen gas. So I hope this video has been useful and best of luck with learning everything about your fuel cells.